Next up, we have an inspiring workshop focusing on building AI applications. Thanks for everyone, everywhere, even without the internet. And our speaker is a renowned Google developer expert for Flutter, known for pushing the boundaries of what mobile apps can do. Please welcome Festus Olusegun. Sorry if I pronounced not correctly. And presenting your workshops. Let's start. I stop sharing. Feel free to share, and you can introduce and pronounce your surname correctly.
Yeah, no problems. 1 minute to share my screen.
At the bottom should be share screen button.
Okay. Okay, share screen button.
Sometimes it is take time.
Still coming up, I think. Try again.
Okay.
It's not working. Not sure why.
So you have presenter mode and moderator mode.
Okay, I'll try again.
And is this button visible? Share screen button. Yes, it's visible.
Yes, it's visible, but it's just not working. I keep tapping and tapping. Okay, I
Mhm.
can see it now.
Yes, now we can see your screen.
It's. I think there is a there is a bug. This keeps popping up. Keep trying to cancel. Okay.
Perfect.
All right. Yeah. Thank you, everyone. Welcome to my talk. Today I'll be presenting on build building AI-powered Flutter apps that works without internet, cloud, or costs. So first of all, who am I? My name is Festus Olusegun. I am a product engineer at Trade, where I currently work on B2B products. I am an early Flutter adopter. I've been using Flutter since I think 2018 or thereabouts. Um, and I'm a GDE, Google Developer Expert for Flutter and Dart. So why this topic? A few months ago, I had this idea to build an app that needed AI that used AI to express that helps people to use AI to express themselves better. So the idea was nothing crazy. It's just you put in some texts and the AI basically um, detects your mood, and also it gives you a bit of an emotional message to cheer you up or to encourage you, depending on your mood. That is. So, it was very, very easy to build. What I did what almost everyone would do. Add my generative AI package, the Firebase AI logic, added to my Flutter code, and I added my API key, which I got from Google AI Studio, and everything was working beautifully. So that was the simple idea, right? And then I stumbled upon a very, very surprising solution, a surprising problem, sorry, which was, it got to a point where I didn't have internet on my device. I think I was somewhere without internet, and then I needed to kind of like express myself to the app so I can get some mood detection and emotional support text. And that was when I realized that, oh, the app is not going to work because I have no internet. So that was a surprising problem for me. Uh, I mean, it's not something that happens every day, but it was a problem. Also, another problem was also privacy concerns, because there are people, when I give the app to people to test, there are people that were kind of skeptical about putting in, you know what's on their mind, because the AI is on the cloud and they don't know where the data is going, and blah blah blah. So privacy concern was also another problem that I kind of encountered with users specifically, and that was when I thought about it, like, how can I call my app a smart app when basically it becomes useless without internet? And that was a motivation for me to go ahead and start researching on how I can um, add the AI without internet. Because imagine you're on the flight without Wi-Fi, and you need an AI chat. You need to maybe chat with the AI to ask a question, or um, you need to translate something, and you don't have internet. Somewhere along the journey, I stumbled upon an exciting solution, and that solution is called Gemma. So the Gemma models, they're small enough to run locally, and they're smart enough to be useful, and also they're pretty fast enough to actually ship um, good products. So today's workshop is basically going to be me sharing the stuffs I wish I knew, or someone had told me earlier, uh, and that's how to build, you know, um, how to build AI powered apps without that doesn't depend on internet, cloud, or some API key or API quota that you forgot to like top up or something. So what are the problems we have with cloud AI? Like I just said before, number one, it requires internet. So cloud AI is it's basically that one friend that functions when everything is perfect. So without internet, nothing works. It's smart, but without internet, it's really not so smart. And there are some regions, there are some cases that this might be a problem. Even with good internet, you might still get some delays because of latency issues. Uh, it can be expensive for scale. So during test, you're building a very simple app with a few users. It's all simple. It's all vibes. You're enjoying yourself, and then you launch. You start getting hundreds of users, thousands of users, and then you start seeing that your API bills are climbing up. You know, and that can be pretty frustrating. Another issue is privacy concerns, like I mentioned before. Some users, they want to know what is being done with their data, and when you're using cloud AI, there's a lot of ambiguity around that. The users, they don't know what's going on, and that can cause some problems. Fifth one is API keys and quota. I think this is something I actually experienced before. There was a time I was building an app that was using ChatGPT API. I would ChatGPT API, OpenAI API. You have to basically buy credits. So the there was a point where I was getting more users than I budgeted for, and because of that, the budget was moving really quick. Before I knew it, I was getting emails about my budgets already passing my credit already passing 50%, and I was very very worried. At some point, so one day I slept, I woke up. The next thing, the entire credit was already done, and the app basically stopped working. That was another problem I had with cloud AI. And why does offline AI matters? Because it works everywhere. If the model is on your device, your AI will work whether you're on a plane without Wi-Fi or on a bus, or even if you're in a village with a very very bad reception or some remote area, it's still going to work. You get faster responses because you don't have to send an API request to the server, and basically a round trip to the server, and it's private by default. The model is on your device. Nothing leaves your device. No servers, no third-party endpoints, no background logs, nothing. Everything is on your device. You can trust it for anything personal, journaling, well-being message, anything, and no API costs. That's something else. Your wallet can breathe freely because you don't have to pay for API costs. Once the model is downloaded on the device, you don't need to pay any cents, any dollar, nothing. And a stable user experience. There's what's wrong with the cat? There is no network drama, no errors, no issues. Now, like I said before, during my journey researching the offline ways of using AI, I made Gemma. So, what is Gemma? Gemma is part of Google's family of open, efficient language models. They are not huge. They don't need a lot of VRAM and so on. They are very, very small and practical. They were made to be intentionally small and practical so it can work on your devices. Um, 2B and 7B parameter sizes, I think that's with Gemma 3. And they're efficient and developer friendly. Gemma was designed to be easy to play with, um and yeah, so because of that, it's developer friendly. It works great on device. Gemma is one of the few models that can practically run fully offline while producing good and useful text. No cloud, no server, nothing. Everything happens locally. And lastly, it's open and accessible. No secret API, no black box. You download the model, load it in your app, and you're good to go. So, how does on-device LLM work? Um, so there is a GGUF model formats, quantization. So to make models smaller and faster, it gets quantized. Uh, quantized, sorry. It's just a fancy way of saying that we trade a tiny bit of accuracy to make the model much more lighter and much more efficient. This is what allows a 2 billion parameter model to live happily inside your Flutter app. There's local inference. All the AI magic happens on your device. No cloud, no API calls, no servers, nothing. Your phone basically becomes the AI engine. Uh, Now, memory constraints. The main limitation is RAM because your phone is not a server. They need smaller models, careful loading and efficient prompts. That's why these models are quantized. And then no server round trips, no need to call any endpoint. So no latency, no 500 errors, just pure instant inference straight from the device. Now, for us to use Gemma on Flutter, because the entire point of this talk is building Flutter applications that works offline without cloud costs and with good privacy. So there is a package called Flutter Gemma, which is what we'll be working with. So this package allows us to run Gemma fully offline. It has that APIs that are very, very clean, and it makes it easy for you to initialize the package, load your model or download your model, pass in the prompt, get a text back. It feels very, very easy to use. Uses local models. I mean, you can actually download. It also allows you to download, like it has a way for you to download the model. And you can also use assets. But yeah, it's all local. No backend required. You don't need Firebase, you don't need Cloud Run, you don't need your server, you don't need any of those things. Just Flutter, your phone, and the model, and you're good. Also, it works on mobile and web. So Flutter Gemma allows you to run the model also on Flutter web, which is a good thing. So now I have a bit of a demo, should I call it? I will have to share my code, my IDE, so we can see how we can quickly build something simple with Flutter Gemma. Stop sharing for now, and minutes.
The phone is now charging.
Okay. Um. Okay. I think I have this here. Okay. Yeah. Let me know if you can see my. Okay. I think my screen is quite visible. So select this. Currently, I have the product we'll be working on today is a very simple app. So it's just it's going to be a one-page app with a text field where you can input something like, just say something like I'm tired, and or I'm happy, and the AI kind of takes your text. It takes your text, it analyzes it, detects your mood, and then it gives you a simple um, some words of encouragement or something to complement your mood. So I already have in case anyone wants to follow along, I'm going to drop the link to the repository so it can be easy. There are currently two branches. The master branch has all the code with both the UI and the AI. And then there is a branch called UI. So that branch only has the UI code. So if you want to follow along, you can probably pull the UI branch, which only has this UI. So just this. Here we have a button. When you tap the button, ideally you should load and say something about your mood. Right now, these are all placeholder texts. The AI is doing nothing for now. Looking at the code. So in the code, we have a lot. We have to do here to implement the AI, and everything here
On
is
your
just.
screen is not visible.
Oh,
It was
think
visible, but not now.
I think yeah. Okay, I think it stopped sharing. 1 minute.
Oh,
Okay, I
perfect.
think. Okay, good now. So yeah, I was saying that we have the to-do here to implement the AI. So this is just UI code. Okay. So I think I already added the link to the master branch, and this is the link to. Since I didn't go through.
Not visible screen.
It's going to be a problem.
No, it's okay.
All right. So for us to start, we will be adding the Flutter Gemma package to our PubSpec here. So I think the latest version now is Flutter Gemma 0.11.9. Once we have that, we have to initialize. Flutter Gemma. Oh, I have to get the dependencies first. Let's initialize. For this to work, we need to add the. Okay. And now that we have the Flutter Gemma package in and we have it initialized, we can then load the model. So we'll do that in here. So what we want to do now, probably we can add a boolean, say is installing model. Just gonna make it true, because the thing about Gemma is, since the model lives on the device, you need to actually install it. Sometimes you actually even need to download it. So when the user is opening the app for the first time, you can download the model and then install it. That way, anytime they open the app again, they don't have to download it anymore. So what we're going to do, we're going to have is installing model, and we can add this here. So if the model is being installed, we want to show a progress indicator center. So now we can actually write the function to install the model. Okay, set states. And first to do this, Flutter Gemma. Let's install model, and the model type is Gemma. So now we can either install from network or from assets. And here I already added a Gemma 1B model here that we can use. So I'll be installing from assets. Slash path slash models slash, I have to copy the name. And install. So since I'll be installing from assets, I need to add this to my pub spec. Here. Perfect. So once the installation is done, we need to install model, change install model to false, so the circular progress indicator can leave. I think the next thing, we can install the model in the init states. Okay, so this is after the second step. The first step was adding the package and initializing it in the main. So the second step would be for us to actually install the model, which we are installing from assets, because we have it in our assets folder. And the next step would be to then work on the actual generation. So I already have a method here, which is analyze mode. And currently it's just a placeholder. It doesn't really do anything. So now I can transform this. I can go ahead and transform this method into something that actually uses the model to analyze the user's mood. So we can start by, we have a text editing controller here, which is attached to the text field we have on the screen. So we can start by collecting the inputs. So inputs, the texts. Oh, smooth controller, that's value the texts. So if trim, in case there's just a space. So if inputs is empty, we can just stop running the method. Okay, so here we have it's loading, it's true, and then here we can remove all this and actually run the model. So we can have a try catch, and our try, we can have the model. So here we need to get the active model. Here, final inference model is equals to awaits outside Gemma dot get active model. The awaits is redlining, so we need to change this to a future. Okay. Yeah, just to move faster, I can just try getting this. So here we have now we have our model ready, to be used. So now we can create a chart. After we get the model, we can then create a chart. Model dot create charts. And in this create chart, we want to add a bit of, shall I say, system instructions. So I'll be copying that. I'll be adding. So here we have some system instructions for the AI model. So we're saying you're an emotional support analysis assistant. Your job is to read the user's message and output only valid JSON. So in the JSON, we want a mood and want a message. So the mood must be exactly one word, and the message must be a short supportive sentence under 15 words. And so now that we have this, we can then add the user's message, which is this. So here we can add the user's actual inputs. So here we have the inputs, and we're also telling the model to remember to only respond in JSON formats. So once we have all this, we've passed in our system instruction and the user's message. We can then generate the response. Basically get the response from the model. Chat dots generate chat response, and so here we can create a string response. We call full response. So because the model response class is an abstract class with several types of response. There's text response, function call response, thinking response. So we have to check, we have to basically assert that we are getting back a text response, not something else. So here we can add an if statement. So if response is text response, then we assign the response token to the full response. Now I'm going to copy the code to basically pass the JSON. So here, there's a new code I just added. So here, this code basically kind of cleans out the response from the AI, because I noticed that the AI with the instructions I added, the AI usually add this markdown to the response rather than just giving me the JSON. So I'm sure with a bit of fine tuning, that should not be happening, but right now it is. And so I have to like basically clean out the response, make it only purely JSON. Then I can then do JSON decode, and I get the mood and the message from the JSON, and then I can call set states. Can call set states. Assign the detected mode to mode, and message and also it's loading. And one more thing I like to do is to just clear the history of the chats, since it's only being used for one thing and one thing only. So in the cache, just add this. Oh, yeah, in the cache. Okay, this is the cache I need to add this to. So if anything happens with the text generation, we need to, uh, tell the user that there was an error and we need to stop the loading. So I think we have we've done all the necessary steps. We've initialized the plugin, the model, and we've also done the text generation. So I'm going to go ahead and run this again, and let's see if it works. Oh, actually, it won't. I need to do some more configurations around the pod file. This needs to be 16. I think here I need to add this. These are things you can find in the documentations, by the way. So these are just necessary setup procedures. So now we have to wait for this to run. It might take a bit of time. Let's hope it doesn't take too long. Oh, the sharing stopped. One
Yes, no.
minute. 1 minute. Again. Okay, now it's also installing. The installation might take a bit of time also because it has to copy the entire model file since the model is being added as an asset. Also something to think about. Uh, yeah, so when if you're loading the model as an asset, the model is going to get bundled with your app binary, meaning your APK or your IPA. So the size of the app of the download is going to be very, very big. Okay, so now I think the app is running. So if I write something like I feel let's just use I feel tired or something like that. Okay, so now it's generating a response. Might take a bit of time. So once I write that, the model takes what I wrote and it takes my mood and it gives me a message. So I can say can just try something else. Very, very happy, and we should do the same thing. Yeah, so it detects my mood and it says my mood is happy and it says you're doing great. Let's enjoy this moment. And all this is all being done locally. So if I believe I turn off my Wi-Fi and maybe I go to airplane mode, it will still work. But I hope the connection doesn't get severed. So it's turned on airplane mode. Oh, yeah, the mirroring got disconnected. I'm currently using my iPhone, so so I guess that will be possible right now. But yeah, if you turn on, in theory, even if I turn off my Wi-Fi, I turn on airplane mode, it will still work. If I'm in a remote village or on a plane without Wi-Fi, everything's still going to work just fine. I can still, detect my mood. Or if you're building a chat app that works offline, you will still be able to chat with the AI. And it's also multimodal, so you can also upload images, media. It doesn't only support text. Basically, that's what it means to be multimodal. Um, yeah, so that's the demo. I should probably stop sharing the screen and go back to the
Uh,
slides.
until you didn't. Okay. I have a question for previous step. You installed from assets, but where did you download Gemma 3? Can
Okay.
Yes, because for example, I'm new in this and I just explore Flutter Gemma package and here
Yeah.
nothing about uh, downloading exactly Gemma. So you can install this package and here few models, not only Gemma, even DeepSeek.
Yeah, yeah, yeah. True.
Yeah.
Yeah, I'll get. I think I'll get to that. Just sorry, I still have a few more slides uh to go.
Okay.
Let's, let's see. Share my screen. I think this. Okay, can you see the screen?
Loading. But maybe I have issues with internet because I see that you share something, but here was just black screen, not presentation. Oh,
And
perfect.
now,
Demo, demo.
perfect. So now we're going to go into performance tips. So if you want, if you don't want lag, you don't want chunks. So it's usually better to go for I'll say smaller models because on a mobile device, the size of your model matters a lot. If you're going for 7B, the 7B Gemma 37B, it will work, but just because it's so big, it can also cause some performance issues on some smaller devices. and warm load at app startup. So don't wait for the user to tap the send button before you actually load up the model. So it makes sense to basically load the model when the app starts. So when the user is ready to press the send button during the chat or during whatever they're doing, the model is already loaded and ready to use. So keep prompt short. Large prompts means more processing and more wait time. So a small focused prompt gives faster answers and it uses less RAM. The RAM usage is very important here because everything is being done on your device. Cache the model. Once you load the model into your memory, keep it alive. Don't don't uh, don't try to reload the model all the time. And another thing is use isolates if needed. So we all know. I think as Flutter developers, we know what isolates are. They allow us to do more concurrency, and every processing tasks on our app without you know um, dragging the resources on the main isolates, basically making the app lag and jank and causing jank. So if you notice that you're having some UI lag, it makes sense to kind of like push the inference to a background isolates. So your UI the main isolates can stay smooth. So some limitations, offline on device AI models, they are not it's not magic. There are some limitations to it. For example, the model sizes are quite big. Like the one I just used now, I think it's about, so I have to check, but I think it's almost 1 gigabyte. It's about 700 megabytes. Yeah, almost 1 gigabyte. And that's even a smaller model. It's not a bigger one. So if you're going to bundle this with your app, like allowing the users to download from assets, that's going to make your APK or IPAs big. So it makes sense to go for the smaller models or use download for network. So that way, when the user opens the app from the first time, they make sure they have internet, they download the model, and the model stays on their device without having to like bloat your app size, your APK size. Limited knowledge. So these models, they don't have up to date facts, unlike the cloud AI. They don't know the latest news. They don't know the latest frameworks. They don't know who won the football match that happened yesterday. They don't know what football match is going to take place today. They don't know any of these things, and they are slower on older devices. I'm currently using an iPhone 14 Pro, and I feel the lag from time to time because I think my phone is about 3 or 4 years old now. Versus if you're using it on a newer iPhone 17 or the iPhone Air. Short context window on device models can't handle huge text input. So you can't dump a 10-page essay on your on device model, unlike the way you can do that on with let's say ChatGPT or Gemini. So another thing is no cloud level reasoning. Offline models, they are great for writing, summarizing, simple reasoning, idea modes, maybe translations, but they can't beat like cloud AI models when it comes to like deep logic or complex task reasoning and so on. Some alternatives and related tools. So right now we spoke about Gemma, but there are also other alternatives, just like Whisper.cpp. So Whisper is very good for speech to text. So if you're looking for an offline model for speech to text, you might look at Whisper, TensorFlow Lite. There are also other LLMs like Phi, Queen, Llama, Mistral, DeepSeek, and so on. So and also you can also think of combining offline and cloud. Maybe you can use cloud when the user has internet, and use the on-device model when there is no internet. So some resources, can check pub.dev for Gemma. So if you're looking to download the Gemma models, you can check Hugging Face. But actually, the one I used just now, I got it from kaggle.com. Let's see if I can find the link. Gemma 3. Yeah, I got it from. I'll add the link to the charts, so you can get it from Hugging Face or Kaggle, or can get them. You can also check the model docs if you want to understand, maybe have a deep understanding of how these models work. You can check samples and demos. If you go to the Flutter Gemma repository, you find some nice demos there. And you can also connect with me on LinkedIn, Twitter, if you have any more questions. Yeah. Thank you. I think that's the end of my presentation. Any questions? Questions are welcome. Yeah.